Okay, so to find out the reminders, there is an important concept we have in the number system, that is nothing but Totient method. Okay, so by using this method we will find out the reminders of lot of problems. So that's why this concept is very important. So by the way, what is Totient method? So that before we would discuss about the Totient method, let's understand what is a coprime. So because Totient method is related to the coprimes. In the definitions of numbers, different numbers, so we have seen that what is a coprime. So what is a coprime? So generally if two or more numbers have only one common factors, those numbers are called coprimes. Suppose if I take the numbers 4 and 9. So what are the factors for 4? The factors for 4 is 1, 2, 4. What are the factors for 9? 1, 3, 9. Okay. So how many common numbers we have? Only one number. So coprime definition is if two or more numbers have only one number as common number, so those numbers are called what? Coprime numbers. So I can say that these numbers are what? Coprimes. Okay, 4 and 9 are coprimes. Okay, likewise we have, so we can take any numbers, 2 pair of numbers, 3 pair of numbers, any number of pairs. So if we have only one common number, such kind of numbers are called coprimes or relative primes. So this thing we have already seen in the definitions of the number system. Okay, so to find out the reminders concept, so we use this one, coprimes. So by the way, if I ask you that, how many coprimes are there to the number 9? How many coprimes are there to the number 9? Okay, so let's see that. We'll write all the coprimes to the number 9. Can I say 1 and 9 are coprime to each other? Yes, 1 and 9 are coprimes to each other because we have only one such number, only one common factor. Can I say that 2 and 9? Yes, 2 and 9. So we have only one factor for both the numbers as common. And 3 and 9, yes, I should not take 3 and 9 as a coprime because we have 3 as a common factor for both 3 and 9. So which is not true according to the definition. So that's why we don't take 3 and 9 as a coprime. And 4 and 9, yes, I can take 4 and 9 because there is no other common factor we have. Yes, I can take 5 and 9. Can I take 6 and 9? I should not take 6 and 9 because in both the numbers, so we have factor 3 is common other than 1, right? And we have 7, 9. 8, 9 is also. We have 8, 9. So which means that how many coprimes we have? So 1, 2, 3, 4, 5, 6. So the number of coprimes to the number 9 is what? How many coprimes we have? Yes, we have 6 coprimes. Is it clear? So we have 6 coprimes. So by the way, it is not possible to write coprimes to a particular number if the given number is a very big number. Suppose if I say that, so 240. So what is the, how many coprime numbers are there to the number 240? Is it possible to write all the numbers starting from 1 to 240? No, it is very time consuming, right? So that's why we use a method called Totient. So the name is not important. So if you're asked to find out, so how many coprimes are there to a particular number, then so this is a very important method. So which we are following to find out the quotient method. Okay, so which we are following to find out the number of coprimes. So the number of coprimes is equal to number of coprimes to any particular number, 9 or any number. So that is what. So suppose if the given number is written in the form of a1 to the power of p1 into a2 power of p2 into up to so on an power pn. So where a1, a2, a3 and so are all prime numbers. What are these numbers? Prime numbers. Which means that first we need to write the given number as a product of prime numbers, and after that, so the number of coprimes is equal to, generally the number of coprimes is represented by pi of n. So is equal to n into 1 minus 1 by a1 into 1 minus 1 by a2 into something so on. So how many coprimes we got for the number 9? So we got actually 6 coprimes. So by the way, we check by using the Totient method. So first I immediately need to write the given number as a product of prime numbers. To find out the number of coprimes by using the Totient method, first immediately you write the given number as a product of prime numbers. So 9 means that how do you write the 9? 9 is 3 square. Okay. So now the number of coprimes to the number 9, pi of 9 is equal to the number into n into means that the number into 1 minus 1 by a1. So here I have only one prime number, so it depends on how many prime numbers we'll get. So here the first one is what? 1 minus 1 by a1. So 1 minus, we have only one number, so 1 by a1 means that what? So 1 minus 1 by that particular prime numbers. Okay. So the final answer is what? 9 into 1 minus 1 by 3 is what? 2 by 3. So 3 3 is 3 into 2 is what? 6. That is what we got. So how many coprimes are there to a particular number? So then immediately remember this concept. First you write the given number as a product of prime numbers, and later so number into 1 minus 1 by those numbers. Okay. Let's look at different numbers. Suppose if I ask you that, so pi of 9 value, so I already find this one value, so that is what? Pi of 9 value is 6. The number of coprimes to the number 9 is what? 6. Suppose if I take the number 153, if I ask you that how many coprimes are there to the number 153? Okay, first immediately write the number as a product of prime number. So prime number means that 17 9s, okay, 17 9s 153. So because 5 plus 3 plus 1 is 9, and 9 17s, if you divide with 9, 9 17s 153. Okay. Anyway, by the way, if you are good at tables, so immediately we can say that 17 9s 153 can be broken as what? 7 into 153. Okay. So again, by the way, 9 is what? Not a prime number. So then immediately write it as 3 square. So 153 is what? 153 is 3 square into 17. Now, so first I need to write the number. First pi of n value is equal to what? First I need to write the number. Number is what? 153 into 1 minus 1 by a1. What is the a1 value? So a1, a2, a3 is nothing but prime numbers. Okay, 1 minus 1 by that prime number. 1 minus 1 by 3 into what is the next prime number? 17. We don't mind about the powers what we get. Okay, so only we are interested to look for base numbers. So what is the next number? 1 minus 1 by 17. So clear. So 153 into 1 minus 1 by 3 is what? 2 by 3. 17 minus 1 is what? 16. 16 by 17. 17 3s are 51. 51 3s are 153. So 3 2s are 6. 6 16s are 96. So what is the final answer? The final answer is 96. Suppose if you are asked to find out how many coprimes are there to the number 153, how many coprimes we have? 96. How do you find out? You first take the number, that number into, first immediately write the number as a product of prime numbers. You know how to find out that. So 153, we have already done how to find out, how to write the given number as the product of prime numbers by using the factorization method. Okay. So immediately after writing the prime numbers product, so you take the number into 1 minus 1 by the given prime number. So it depends how many prime numbers you will take. So here I will take 2 prime numbers. So 1 minus 1 by 3 into 1 minus 1 by 17. So what is the final answer? The final answer is 96. Let's take another example, 150. So 150 means that, so immediately write the number 150 as what? 150 means that, yes, 25 6s, 25 6s means that, so we have 5 square into 2 into 3, right? Isn't it? So 5 square, 25 into 6 means that 25 means that 5 square, 6 means that 2 into 3. First thing, immediately write the number as a product of different prime numbers. I wrote it, and after that, so pi of 150 value. So pi of 150. So generally the number of prime numbers is represented by pi of some number. So here 150 is given, pi of 150 is 150 into the given number into, so 1 minus 1 by 5, that is 4 by 5, into 1 minus 1 by 2, which is 1 by 2, 1 minus 1 by 3, which is what? 2 by 3. So 3 2s are 6, 6 5s are 30, 35s are. So 5 4s are 20, 22s are 40. See how many co-primes or relative primes are there to the number 150? So we have 40 co-primes or the relative primes to the number 150. Clear? Let's have a next number. See the next number, 245. So 245 means that, so immediately I can say that 5 4s are 5 9s are. So this is nothing but 5 into 7 square. So pi of 245 is equal to what? Pi of 245 is equal to the given number 245 into 1 minus 1 by 5. Okay, so 1 minus 1 by the prime number. So 1 minus 1 by 5 is 4 by 5 and 1 minus 1 by 7. So which is what? 6 by 7. So 5 3s are, so 5 4s are, 5 9s are and 7 7s are. Okay, so 9 4s are 36 into 6 is what? 216. So what is the final answer? The final answer is 216. Okay, so the number of co-primes to the number 245 is what? 216. So likewise we find out the number of co-primes to any number by using the concept of Totient, that is called Totient method. However, the name is not important, just remember the concept. How do you find out the co-primes, number of co-primes to a particular number, right? Okay, now by using that concept, by using the concept of Totient, we can find out the reminders of many problems. Okay, so now we'll see different type of problems we have to find out the reminders. The first case is, in this we have a different method, Fermat's method. Okay, and this is a very important method, Fermat's method, to find out the remainder if a problem is given in a particular sequence. Okay, so that is called Fermat's method. Again, the names are not important. You don't need to bother about the names. You don't need to by heart the names. Only thing is just remember the procedure. Okay, the Fermat method states that if a to the power of pi by p, pi by b, pi into b, pi of b divided by b, if any number is given in this format, the remainder is 1. Okay, what is that? If anything, so suppose if I want to find out the remainder of any number which is in the form of a to the power of pi of b divided by b, then the remainder is what? 1. Okay, if you see this one, so what is pi of b? So pi of b is nothing but, so for the denominator part, so if you take the number of co-primes, that is nothing but pi of b, that should be equal to a to the power of that power. So which means that the number of co-primes to the denominator must be a power of what? Numerator base value. See, let's take this example. Suppose if I take this example, 4 to the power of 6 divided by 7. 4 to the power of 6 divided by. So first you find out the number of co-primes to the number 7. So first immediately, so find out the number of co-primes to the denominator part. So what is pi of 7 value? Pi of 7 means that you know how to find out pi of 7. So 7 into the given number. So by the way, 7 is what? 7 is a prime number. So I don't need to separately write it as a product of prime numbers because it is already a prime number, right? So 7 into 1 minus 1 by a prime number. 1 minus 1 by 7 means that 6 by 7. 7 get cancelled. What is the value? 6. So what is pi of 7 value? The pi of 7 value is 6. If this pi of denominator is equal to the numerator power, so what is power of numerator? Power of numerator is nothing but 6. So which is nothing but pi of 7, right? If pi of this number is equal to this number, then we immediately say that the remainder is what? So the remainder is always 1. So the remainder is what? So the remainder is 1. Is it clear? So if a to the power of pi of b divided by b, if any number is in this form, then immediately without second thought the remainder is 1, which is one of the important models in finding out the remainders. So please remember that. So Fermat method is very important. So you can see quite frequently kind of questions like this. Okay. So let's look at the next one. What is the remainder of 2 to the power of 100 divided by 101? Okay. when you are supposed to find out the reminders of different numbers, so first immediately take the denominator part. So pi of 101. So 101 means that, so this number is nothing but what? This number is itself is a prime number, so I don't need to separately write this. So prime number into, so the given number n into 1 minus 1 by n is equal to pi of n is equal to what is the formula? Pi of n is equal to, see, pi of n is equal to what? Pi of n is equal to n. So which means that given number into 1 minus 1 by prime numbers, right? Here 101 is already a number, so n is equal to what? The only prime number we have 101 only. So 1 minus 1 by 101. So here I'll write one more step, actually not required, but if you need a careful observation, so if you need a perfect elaboration, then 1 minus 1 by 101. So 101 into 101 minus 1 is what? 101. So 101 get cancelled. So what is the pi of 101 value? So pi of 101 value is 100. So if this number pi, so this number of co-primes is equal to the power of the numerator, then immediately answer is what? The remainder is 1. Okay, that is what the Fermat's theorem states, right? You take next example. If you take the next example, so first immediately, so the first step I had to find out is, so just take the denominator and find out the totient of that number. So pi of 13 is a prime number, so n into 1 minus 1 by 13, so which is nothing but what? 12 by 13. So 13 get cancelled. So 12 is the number we have. Totient of 13 is what? 12. Okay. Now is the totient of denominator is equal to the power of the numerator? Yes. Totient of 13 is 12, so which is there in the numerator power. So the remainder is what? So immediately the remainder is 1. Is it clear? Okay. So the next number. So the next number is, so remainder, what is the remainder of 7 to the power of 82 divided by 11? So to find out the remainder of any problem, so first immediately find out the denominator's totient number. Okay. So denominator number is what? 11. So pi of 11. So by the way, 11 is also a prime number, so I don't need to separately write it as a product of prime numbers because we have only 11. So 11 into 1 minus 1 by 11. 1 minus 1 by 11 means that 10 by 11. 11. So what is pi of 11 values? So 10. Now what is the power of numerator? 82. So which means that both are not same. Okay. Now the second condition is, if power of this number, if power of some number is not equal to pi of or totient of the denominator, then what do we do? How do we find out the remainder? Now you remember one thing here. So now the next step is, after doing this, if the power is not same as the totient of the denominator, then the next thing we have to do is immediately divide the power with the totient number. Immediately divide the power with totient number. What is the totient we get? 10. So divide with 10. Now, so write down the remainder of this number. 7 to the power of 82 by 10. 82 by 10 means that what is the remainder we'll get? 2 only. So what is the remainder when 82 is divided with 10? 10 8 is 80, remainder is 2. So 7 square divided by 11. 7 square means that what? 49. 49 by 11, the remainder is what? The remainder is 5. Okay, so this is your final answer. So if I ask you that what is the remainder of 7 to the power of 82 by 11, the final remainder is what? 5. How do you find out? So simple. First, for any problem, if you want to find out the remainder of a particular problem, so then immediately find out the totient of the denominator number. And after that, if you get the power of numerator and the totient of this denominator both are same, then the remainder is 1. If it is not like that, then divide the power of numerator with the totient number and you get some remainder, right? So the remainder, you are just simplifying this remainder. From 82 you are simplifying into 2. So now the problem becomes easy, right? 7 square is 49, 49 by 11, 11 4 is 44, the remainder is what? 5. Okay, is it clear? Let's see one more problem. So what is the remainder of 32 to the power of 50 divided by 9? Okay. See, before we approach it, so remember one more point we already discussed in the previous class. Suppose if I have something like remainder of some a into b into c into up to something, any number of values, if I divide with some particular number, I already told you that you can split it like, so remainder of a by x into remainder of b by x, right? So remainder of c by x. So likewise we can split the complete number into different segments, right? So that we have seen in the previous class, the basic fundamental rules of remainders. So here suppose if I have the 32 to the power of 50, so 32 can be written as what? 32 into 32 into 32 into, so how many times? 50 times, divided by which number? 9. So for the complete number I had to find out the remainder. So since the whole product is dividing with one single number only, can I divide like this? Can I write it like this? So remainder of 32 by 9 into remainder of 32 by 9 into remainder of 30, likewise 52 times, right? So what is the remainder? Will get 32 by, when I divide 32 with 9, so 9 3s are 27, the remainder is what? 5 by 9. So each time I will get 5 by 9, right? So now the problem becomes what? So 5 into remainder of 5 into 5 into 5, how many times? 50 times. So the same thing, can I say it simply without writing all these steps? So 32 by 5 remainder is what? So that 32, the remainder of 32 by 9. The remainder of 32 by 9 is what? Yes. First, you just forget about the power. First you take this one. Okay. If you are dividing a larger number with the smaller number, first you simply take the remainder of this number. 32 by 9 means that what? 9 3s are 27. Okay. First we write the simplified form of this number. So 9 3s are 27. The remainder is what? 5. 5 to the power of 50 divided by 9. Now finding out the remainder of 32 to the power of 50 divided by 9 is as same as finding out the remainder of 5 to the power of 50 divided by 9. Okay. So now we have to find out the remainder of 5 to the power of 50 divided by 9. Okay. So as usual, first thing is what? The first thing is I had to take the totient. I had to find out the totient of 9. So 9 means that first you write it as a product of prime numbers. So 9 is not a prime number, then immediately write it as a product of prime numbers. Now 9 into n into 1 minus 1 by that prime number. So 1 minus 1 by 3. 1 minus 1 by 3 is what? 2 by 3. Is it okay? So now 3 3s are 9. 3 into 2 is what? 6. Okay. So by the way, this totient number and the power of the numerator is not same. Then what should I do? Then immediately I had to divide the power. I had to divide the power with this totient number. What is the totient I have? 6. Okay. So 50 by 6. 50 by 6 means that what is the remainder I'll get? The remainder I'll get is 2. So it becomes what? 5 square by 9. Okay. So 25 by 9. 9 2s are 18. 9 2s are 18 means that what is the remainder? The remainder is 7. Clear? Okay. Simply first take this number as usual and then you write the remainder. Let's do next one. So the next problem is 2 to the power of 100 divided by 153. What is the remainder when 2 to the power of 100 divided by 153? Okay. First thing, immediately find out the totient of 153. No need to write these steps. So 153 means that how do you write it? So 3 into 51, 17 3s, which means that 153 is what? 153 is 3 square into 17. This is how I write the number as a product of different prime numbers. Now n into, what is the n value? The n value is nothing but, the n value is 153. n into 1 minus 1 by a, 1 minus 1 by a1, 1 minus 1 by 3 is what? 2 by 3. Now I'll directly write this number. The next number is what? 1 minus 1 by 17. So 1 minus 1 by 17 is what? 16 by 17. 17 3s are 51. 51 3s are 153. So 3 2s are 6, 6 6 the 16s are 96. So what is the quotient of 153? 96. By the way, it is not equal to 100. Then what is the next thing I had to do? Then immediately divide the power with this quotient number. The power is what? 96. So 2 to the power of 100 divided by 96. From this you take the remainder. What is the remainder? The remainder is 4. Now it becomes what? 2 to the power of 4 divided by 153. So which is what? 16 by 153. What is the remainder? 116 is divided with 153. In the previous class I told you that when smaller number is divided with the larger number, so what is the remainder we'll get? Smaller number always. So what is the remainder? So the remainder is 16. So what is the final answer? The final answer is 16. Okay, is it clear?